Hello students, myself Patel Hiren Kumar, A, lecturer in Mechanical Engineering Department from Vallabhpuri Polytechnic, Navsari. Today we will learn a subject of Thermal Engineering 1 and we are discussing about steam prime mover. So today we are discussing about velocity compounded of impulse turbine. Here we can see the figure of velocity compounded impulse turbine. Here moving blades are put, guided vents blade also put. This is a casing, this is the exhaust steam, this is a nozzle, and in this part of steam are entering in the nozzle. It's a shaft, and it's a bearing, nozzle, moving blade, guided blade, moving blade, guided blade, moving blade. It's a combination about two stages, moving blade and guide blade. Lost velocity here, condensation pressure is given here. So we are discussing about that. In this type of turbine, the compounding is done for the velocity of steam only. Drop in velocity is arranged in a many small drop through many moving row of blade. Instead of a single row of moving blade, it consists of a nozzle or set of nozzle and rows of moving blades attached to the rotor or wheel and row of fixed blade attached to the casing. તમને ફિગરની અંદર જોઈ તે પ્રમાણે મૂવિંગ બ્લેડ અને ગાઇડેડ બ્લેડ આપેલી છે. તો મૂવિંગ બ્લેડ છે જેનું એટેચમેન્ટ કોની જોડે કરવામાં આવેલું છે, રોટર અથવા તો વ્હીલ જોડે, અને ફિક્સ બ્લેડ કે ગાઇડ બ્લેડ કહેવામાં આવે છે તેનું એટેચમેન્ટ કેસિંગ વડે કરવામાં આવેલું છે. હવે વેલોસિટી કમ્પાઉન્ડની અંદર ધ્યાન શેના પર રાખવામાં આવે, વેલોસિટી ઓફ સ્ટીમ પર. The fixed blade are guided blade which guide the steam to succeeding row of moving blade suitably rearranged between the moving blade and set in a reverse manner. In this turbine, three row of rings moving blade are fixed on a single wheel or rotor, and this type of wheel is termed as the three-row wheel. There are two rows of guide blade or fixed blade placed between the first and second and the third row of moving blade respectively. The whole expansion of steam from the steam chest pressure down to the exhaust pressure take place in the nozzle only. There is no drop of pressure take place either in the moving blade or the fixed blade. The pressure remains the constant in the blade as in the simple impulse turbine. Okay. The steam velocity from the axis of the nozzle is very high as in a simple impulse turbine. Steam with high velocity enter the first row of moving blade and on passing through the blade, the velocity slightly reduces. The steam gives up a part of its kinetic energy and reissues from this row of blade with fairly high velocity. It then enters the first row of guide blade which direct the steam to the second row of moving blade. On passing through the second row of moving blade, some drop in velocity again occurs. Steam gives up another portion of its kinetic energy to the rotor. After this is redirecting again by the second row of guide blade to the third row of moving blade where again some drop in velocity occurs, and finally the steam leaves the wheel with a certain velocity is more or less axial direction. So we can say that arrangement is nothing but splitting up the velocity gain from the axis of the nozzle into many drops through several rows of moving blade, and hence the name velocity is compounded. This type of turbine is also termed as a Curtis turbine. The two row of wheel is more efficient than the three row of wheel. Okay.